Framing. See, there are two types of framing. One we call it as fixed size framing, and the second one is the variable sizing. A packet or the data from higher layers will be divided into smaller chunks or smaller block of data that we call it as frame. So how we can divide the packet into frame? So here we have two types. One is fixed size framing and the variable size framing. The name itself tells what is fixed size framing. Fixed size framing means, so you will be having the frame which is a fixed size. Always the frame size is same. For example, if you fix the frame size as 1000 bytes, for example, just for example, so always the frame size will be 1000. Whether you have 1000 bytes of data or not, frame size will be 1000. If you don't have 1000 bytes, if you have only 800 bytes of data, then remaining 200 bytes will be appended with some zeros. We call it as padding. Some extra zeros will be appended in order to make it 1000 bytes. We call this as padding. Okay. So in the fixed size framing, always the frame size is fixed. So whether you have that much of data or not, so the frame size will be always fixed. If you don't have the fixed size data, then you need to append some extra zeros. We call that as padding. In the variable size framing, the size of the frame is not fixed. You can have variable size frames. Say suppose, we'll take one simple example. Say in the network layer, so the packet size is around 10,000 bytes. The packet size is around 10,000 bytes, just for example. Now I want to convert it into frames in the data link layer. What I will be doing, so suppose if the frame size is fixed as 900 bytes. Suppose the frame size is fixed as 900 bytes. So the first frame will take the 900 bytes from this, that will become the first frame. Then again we'll take the 900 bytes, this will become the second frame. So like that, I can have around 11 frames, each are of 900 bytes. After adding 11 frame, so 9900 bytes is over. I will be left with another 100 bytes that will be considered as a last frame. Here I will be adding around 800 bytes of extra zero to make it 900 bytes. This is fixed framing. This is fixed size framing. So in the variable size framing, so the frame size can be anything. There can be maximum size for each frame. We can define the maximum size. Suppose if I define it as 1000, up to 1000 bytes you can have the frame. So maybe your first frame is 1000 bytes, second frame is just 500 bytes, the third frame is again 1000, the fourth frame can be again around 900. Like that you can have the variable sized frames. This is the second approach. Now, if you compare the fixed size framing and the variable size framing, see, when the receiver has to receive the things, say you are sending the frames one after the other. So if it is fixed size framing, you don't have to add any delimiter to differentiate. This is first frame, this is second frame, something like that. Receiver knows that the size of the frame is always 900. So after receiving first 900 bytes, after receiving first 900 bytes, receiver will think that the first frame is over. Next, it will treat the second set of frame as the another frame. So it will use that for, it will send this first frame for error control and other processing purpose. Now it start collecting the second frame till you receive the another set of 900 bytes. So it will consider it as a second frame. Again, the next set of 900 bytes will be considered as a third frame, like that. So here we don't want any kind of differentiation. because the size is always fixed. We don't want any delimiter to differentiate. This is fixed framing. Here the length or the size itself acts as a delimiter. On the other hand, in the variable size framing, so the size can be anything. At one time it may be having 1000 bytes, in the another frame 500 bytes, in the third frame again 1000, again 900. How to differentiate that this is first frame, this is second frame? Here the length itself acts like a differentiating entity. But in the variable size framing, we need to append something to indicate this is the start and this is the end of the frame. So here the first frame is starting. This, if you get, the first frame is ending. Next frame is starting, next frame is ending. The next frame is starting, next frame is ending. Like that. So we need to explicitly add something called as delimiters. We need to explicitly add something called as delimiters, which can differentiate between the two frames. So here we have two kinds of approach. One is character-oriented framing and the another one is bit-oriented framing. See, if you consider anything in the network, every layer will add something called as header. We discussed this in the module 1 also. Adding some headers to the data is called as encapsulation. Why headers will be added? This header contains some extra information that is required for a receiver to process. Maybe some address and other information will be placed in it. When the receiver receives this particular frame, it will open the header and analyze what is there in the header and take the decision accordingly. The removing the header from the packet or a frame is called as decapsulation. That will be performed by the receiver. Adding the header to a packet is called as encapsulation. In the character-oriented approach, everything will be in terms of 8 bits only or 1 byte only, because one character means 1 byte. One character means 1 byte. The size of entire frame is variable length, but it should be divisible by 8. Flag means it can contain 1 byte, which is again 1 character, or it can contain 2 byte, 3 byte, but it can't contain 10 bits, 12 bits. Some abrupt numbers are not allowed. It should be in terms of multiples of 8 only. It should be in multiples of 8 only. Whether it is flag, header size also, it should be in the multiple of 8 bits. The trailer should also be in the multiples of 8 bits. And data, what you are going to add, it should be in the multiples of 8 bits only. You can add 8 bit of data, you can add 16 bit, you can add 24 bit, you can add more than this also, but it should be in multiples of 8 bits. You can't add anything in between. So you can't add 12 bits of data, you can't add 14 bits of data. Say suppose if you have only 14 bits of data, you need to add 2 zeros to it in order to make it 16, which is multiple of 8 bits. This is variable size frame only, but the total size of this frame should be in terms of or in multiples of 8 bits only. It should be divisible by 8. That is very important. We call this as character-oriented protocol. Here, what is trailer? See, we discussed error control in the previous chapter. So the error control will involve generating some redundant bit. For example, this data will be taken. You are going to divide it using some divisor. Whatever the remainder you get, that we are going to call it as CRC. That CRC will be appended to the data. That will be used for error detection. So here the trailer contains the CRC if you are using cyclic code for error detection. Even we discussed internet checksum in the last class. This data will be taken and we are going to add, we take rapid sum, we take one's complement. After that, whatever the answer you get, that will be appended to the data and it will be sent to the receiver. So that we call it as checksum. This trailer can be checksum. So whatever you add in the trailer, that will be used for error detection purpose. Whatever you add in the trailer, that will be used for error detection purpose. Whether it is CRC reminder or it is internet checksum's final answer at the sender side, or it may be code word or redundant bit generated using the block coding, or it can be parity bit in the simple parity check or two-dimensional parity check. It can be parity bits. So that will be appended to the data. We call it as a trailer. And what is this flags? The flags are used for differentiating. They are the delimiters. So this is the this particular flag will starting flag will indicate that it is the start of a frame, and the ending flag will indicate that it is the end of a frame. So this is how we are going to construct a frame in the data link layer. There will be a flag, header, trailer. In between, there will be data and also the flag at the end. In the character-oriented approach, it should be in terms of 8 bits only, in the multiples of 8 bit only. But if you take the second approach, which is bit-oriented approach, here you can have 12 bits also, you can have 14 bits also in this variable size, no restriction. So it's no need to maintain in terms of 8 bits. It should not be divisible by 8 bits. Here data can be 121 bit also, which is not divisible by 8. Any value is fine. So it is purely variable length and no need to maintain something with respect to the multiples of 8. Flag can have n number of bits. Header can have n number of bits. Trailer can have n number of bits. The data can have n number of bits. And this n no need to be divisible by 8. But in the character-oriented approach, so if you take these things, if you add n bits for each of these things, n should be divisible by 8. That is the difference. Character-oriented and the bit-oriented approach.